ready to film. I have some really hairy eyebrows. All right, so this new unit is called the integral as a function, which may not mean a lot to you right now, but it will. We're going to continue with the integral. You guys already know about the definite integral. I have another flavor of the integral to introduce to you guys today called the indefinite integral. It works a little bit differently. There's a different question that I'm asking with the indefinite integral. And to make it even more exciting, there will be no calculators used at all in this unit. We are going to get to do everything by hand. So like this would be, you guys know that this represents the definite integral of x squared with respect to x from 1 to 2.
Yeah.
You know that what I'm asking you for is area. How much area? How would you go and find this?
Either you do it according to your calculator.
Everybody would plug this into their calculator if this showed up on a test,
Or
right?
the right point, left
Everybody would do that, or you do a left endpoint, right endpoint, trapezoid stuff. Approximation, yes. No longer will we be doing this on the calculator. We are going to do this like men and women of calculus. We are going to do this by hand. It is going to be a beautiful experience. Suck your teeth now. Get it out of your system. You're going to be just fine. For those of you that are already a little bit in freak out mode, flip over to page 5. Where you'll see all the video support that is already available to you. So there's videos from when I taught this in 2015, 2016, videos when I taught it to the BC kids last year. Feel free to watch all the videos, figure out when I got a particular new polo, which one did I like in 2015, 2016, when did this new sweater come into being, figure out why I seem to look heavier in 2015, 16 than 2016, 2017. I wasn't always the slim man that stands in front of you now. Laugh and die. Just so that we're clear, laugh and your grade goes down. Ashley's here. Hi, Ashley. All right, so she just missed a really good joke. Everybody was laughing and somewhat afraid. Here you go, Ashley. You also missed our conversation about the reassessment opportunity that they'll get you caught up. All right, so let's get rock and roll here. Before we actually start this unit, though, we're going to go back in time, and we're going to talk about the derivative. There once was a time where derivative rules were hard and scary for us. That is no longer the case. Kevin, you can participate, but not tons. There once was a time where derivatives were scary. So if, for example, I said f of x is x to the 4th plus 2x minus 3, I would expect now everybody knows the derivative.
Yes.
Easy peasy.
Yes.
On the count of 3, tell me what the derivative is. 1, 2, 3.
4x cubed plus 2.
4x cubed plus 2, right? Because you're using the power rule here, you bring the power down and reduce the power by 1. You do that over here as well because there's really a secret 1. 1 times 2 is going to be 2. And the derivative of the 3 is 0. It's constant. Easy peasy one, right? Did this in pre-calculus kind of thing. All the handouts are over there. Then things start to get tricky. I start asking you questions like, hey, what's the derivative of sine of x? Derivative of sine of x is? Cosine of x. There, you're frozen for a little bit. Okay, derivative of cosine of x. What do we got? Let's get some hands. So don't call it out, don't call it out. Pedro, you're hungry, I can see. Derivative of cosine of x is?
Negative sine of x.
Negative sine of x. Good. Derivative of, let's say my function is e to the sine of x. What's g prime? I want to get some hands on this, don't call it out. Derivative is, the function is e to the sine of x power. Caleb, what you got? E to the sine of x power times cosine of x. Why are you multiplying by cosine of x? You're right to do that, but why?
Because it's chain.
Because you're using the chain rule. Everybody good? Okay, let's get a little further here. Derivative of natural log of x. I want to get some hands on this. Don't call it out. Derivative of natural log of x. The derivative of natural log of x. Only Pedro? So sad. I'm going to start going for victims, Evelyn. Get yourself ready. Evelyn looks like she'd be a great victim. Ashley, derivative of natural log of x is?
1 over x.
Love it. Oh, nice catch. Look effortless. Derivative of natural log of x is 1 over x. What about the derivative of 1 over x? Derivative of 1 over x. If you don't remember, there's something you could do to get there. Delia?
It's negative 1 over x squared
squared?
Well done. Derivative of 1 over x is negative 1 over x squared. How about derivative of the square root of x? Nahum.
Is it 1 over 2 square root of x?
Well, it is 1 over 2 square roots of x. Well done. How about the derivative of tangent of x? Some of you just have this memorized. Derivative of tangent of x is secant squared of x. Too bad you didn't raise your hand. Sorry! Anybody know derivative of tangent of x?
Raise your hand and say it again.
Oh dear God. Roberto! Secant squared of x. Good. However, derivative of secant of x is... You really want to volunteer before I go much harder.
Is it a cotangent?
Derivative of secant of x is not cotangent of x. Nope.
It's 1 over sine.
It's not 1 over sine.
No, I said it was 1 over sine.
Secant would be 1 over cosine. The derivative of secant of x is secant of x times tangent of x. Epic fail. I keep that one. Okay, derivative of arctan of x. Last one. Derivative of arctan of x.
Let's go secant. Let's go secant.
Oh no, so you're going to raise your hand. And she's totally wrong, so don't listen to her. Derivative of arctan of x.
Let's go secant.
Still not raising the hand and still wrong. Pedro!
1 over the square root of 1 plus x squared.
Oh my God, so close. Derivative of arctangent of x is not 1 over the square root of x squared plus 1. It's close though. Beto?
1 over x squared plus
1 over x squared plus 1. Well done. And favorite calculus teacher?
Mr. DeRozier!
1. No, Rachel.
Why didn't you say anything at all? Just sat there, he's like, I'm going. All right, so now that we've got the derivative stuff in the brain, we're going to reverse the process. You're going to learn to dance backwards. Okay, so with that said, Nahum, can you read from the top, please? Where it says, page 7, it says, until today.
Until today, our knowledge of integral calculus has only involved definite integrals. Integrals of the form definite integral of f of x with respect to x from a to b.
Well done. It was scary for a little bit, but good. Keep going.
We know from past experience that the definite integral represents the area bounded by the function f of x. The x-axis on the vertical line is x equals a and x equals b. In some cases, we have been able to evaluate the definite integral using our knowledge of geometry. In other cases, we have had to rely on our graphing calculator to evaluate this expression. We have also explored properties of the definite integral, worked on application problems involving definite integrals, wave functions, physics problems, etc., and uncovered possible theorems involving definite integrals, the fundamental theorem of calculus, and the average value of a function.
Okay, I want to stop you right there. First of all, this is everything that you guys were just assessed on yesterday. Right, but everything we've done, every single thing we have done up until today was calculator active. We're going to push in a new direction. Kayla, can you pick it up from there?
Now we need to add the indefinite integral.
What was the word again? The indefinite integral. We used to deal with the definite integral, now we're at the indefinite integral. Keep going, Kayla. Okay, well, take a guess. How are you going to read it?
The indefinite integral.
The indefinite integral
of
f of x with respect to x. Love it. Love it, love it, love it. So right away, what's different between a definite integral and an indefinite integral? There's no boundaries. There's no limits of integration. There's no a and b if you want to look at it that way. Kayla, keep going.
Into our toolbox of calculus concepts, the indefinite integral is the function which has f of x as its derivative.
Okay, wait, one more thing. The indefinite integral is the function which has f of x as its derivative. That seems important. Okay, keep going.
In other words, we are looking for the antiderivative of f of x.
Oh, antiderivative. It's been a while since that word. Okay, so this means the following. The indefinite integral of f of x with respect to x is equal to the antiderivative of f plus c. Then it has to be true that the derivative of big F is equal to little f. And if right now you're like, shh, that just went over my head, stay with me. Okay, I want to do a quick vision check. I want to get this in your notes. We've got two flavors. You know, I'm always hungry. Always hungry. Always thinking about food. There's two flavors. There's the definite integral, and we get the indefinite integral. The definite integral, you guys know that notation. It looks just like this. Right? Everybody's comfortable with this? What does it mean? What's the question that I ask or I want you to ask when you see a definite integral?
The area
As a question, it's how much?
the area
How much area? Yep, keep going.
is bounded by the x-axis.
Is bounded by, and now you give me four things. Is bounded by, I heard the x-axis, the function, okay, the function f of x. What else? The x-axis, the function, and the lines x equals a. The line x equals a and x equals b. And you probably have a visual in your head. I always draw the function the same way, I think. Here's a, here's b, and I'm asking you about area. This is our understanding of definite integral. Your answer to a definite integral is a number, and that number represents area. We're good? Sometimes it's a rate function, and it means something a little bit different, but it's still a numerical calculation. Now, just to clarify some vocab here, f, I want to make sure you get this in your notes, is the integrand, I-N-T-E-G-R-A-N-D. The dx is your variable of integration. The a and the b, some of you guys call them the bounds. The proper phrase is these are limits of integration. Limits of integration. And the whole thing together is what we call the definite integral. Okay? We've got the integrand, you've got the variable of integration, limits of integration, and the whole thing together is the definite integral. This is where we've been. Okay, so here comes into the mix indefinite integrals, and the notation looks just like that. Okay, the indefinite integral, there are no limits of integration. So those are already gone. You still have, what's f of x called again? This is the integrand, and the dx?
Variable.
Variable of integration. Okay, variable of integration. And the whole thing together is what we call the indefinite integral. I just want to make sure that you've got a place in your notes that you can refer to all the things. The question being asked is different. The question is, what function, in parentheses we're going to say what family of functions, what function or family of functions has little f of x as the derivative. When you're looking to evaluate an indefinite integral, the answers the question, what function or what family of functions has little f as its derivative? Your answer is going to look like big F plus c. Big F is the antiderivative. I need to get rid of the blue marker. And c is your constant of integration. Okay, so new vocab words there. Big F is the antiderivative. C is the constant of integration. Well, I get a properly functioning marker here. Take a minute, just have some conversation with the folks around you about the new notation. I want to hear you practicing the vocabulary of indefinite integral, of the antiderivative, of the constant of integration. Use the question. Take a minute, get some practice with this. It's important stuff. Great. I'll get black and I'll get black.
One family of functions has f of x?
Has little f of x.
Hope everyone's going to be comfortable with the vocab. It's coming. Let me just finish taking attendance. Alright, attendance is done. Alright, here we go. Pedro, I hope you're ready. This first one is coming your way. Alright, so everybody can go over to page 8. Page We're not going to get through all of these. I'm not even going to try to get through all of them. We're just going to see what we can do. And tonight's homework has nothing to do with the indefinite integral. Pedro, can you read that notation?
The indefinite integral of 6x minus 2 with respect to x.
Love it. The indefinite integral of 6x minus 2 with respect to x. Hey, Zeus, what's the question being asked here? Go back to the other page if you need to. Pedro read this correctly. This is the indefinite integral of 6x minus 2 with respect to x. But what's the question? What function? What function has 6x minus 2 as its derivative? That's the question. Think about that for a second. What function has 6x minus 2 as the derivative? Have you ever seen 6x minus 2 as the answer to a derivative? 6x minus 2. What would I take the derivative of to get to 6x minus 2? I won't tell anybody at all. It doesn't work that way. What would you take the derivative of to get to 6x minus 2, Beto?
3x squared
3x squared.
minus
I'm hearing it from other folks as well. 3x squared minus 2x. Does that work?
Yeah.
You're convinced it works? Convince me that that works. How would you convince me? Right, the check step is just going to be, go find the derivative. And what's the derivative of 3x squared minus 2x? You guys already showed me, you know how to do that. 6x minus 2. The antiderivative of 6x minus 2 is 3x squared minus 2x. Why? Because if I take the derivative of 3x squared minus 2x, this is what I got. And all the friends are okay?
Yeah.
Does anybody know another function that has 6x minus 2 as its derivative? And you definitely don't get to participate here. X to the 6th power is what Jose offers up. Right, if this was true, then you would be able to take the derivative and get 6x. That doesn't work. Anybody else have one? You're frozen for a little bit, Delia?
Oh, no, never mind.
Oh, but what were you thinking of?
6x, but then if you get the derivative, the x goes.
Okay, today is going to just be like let your smarticle particles run wild. There are rules, the rules are coming tomorrow. So Delia was thinking 6x, does 6x work?
No.
Take its derivative, what do we get?
6x.
6, not that. Anybody know another function that has 3x squared, 6x minus 2 as the derivative? What you got? 2x cubed minus 2x, does that work? Take the derivative.
No.
Take the derivative and you get 6x squared. Not this. Does anybody know another one? Does anybody know another function that has 6x minus 2 as its derivative? Kevin, I'm coming your way. Kevin, do you happen to know another one that has 6x minus 2 as the derivative?
Can it be 3x squared minus 2x plus 1?
Does that work?
Yeah.
Does that work? The derivative of 3x squared minus 2x plus 1. Does that work, Ashley? Okay, does anybody have another one? Anybody have another one that has this as its derivative? Pedro is really pissed off that he didn't think about this one. Pedro, don't disappoint. What you got?
3x squared minus 2x plus 100.
Whoa, you went big.
Whoa.
Okay, 3x squared minus 2x plus 100. Does that have 6x minus 2 as a derivative?
Yes.
Anybody know another one?
A lot. There's a lot of them.
Anybody know another one?
Is that what it's called again?
That's part of why we're going to use the phrase indefinite integral. Right, like the indefinite article in English class. Maybe brains aren't going to cross over that quickly. Anybody, how about 3x squared minus 2x plus pi? Does that work?
Yeah.
Absolutely. So the answer, the actual answer is 3x squared minus 2x plus c. Where c, go back in your notes, what's c called? Your constant of integration. The 3x squared minus 2x is your antiderivative. This is the part that we're all going to agree on. And the c is a constant. It could be any constant. And sometimes you'll be given information where you can figure it out. but it's the constant of integration. Miss Blakely at East End, amazing teacher that she is, calls this Charlie. She always says, don't forget about Charlie. Don't forget about Charlie. Where did you leave Charlie? Charlie's at the grocery store. All right, so with that said, see what you can do is beef it up a little bit. Take a minute with your friends. I want the indefinite integral of 10e to the t plus sine t plus 6. We'll talk in a minute.
So it's probably going to be code.
Isn't it just 10e?
10e to the t plus sine t plus 6.
So the power of t, isn't it plus cosine?
So this is actually minus.
See, that's the whole like spring over to my desk. Huh? Make me do all the work around here. Oh, okay.
Come down, boy.
Okay.
So right is 10. What's the power of it? Minus
Huh?
cosine?
I didn't want to like surprise you and scare you.
X is negative
All right.
X. I mean,
Okay, here are some of the answers that I saw in my stroll around the room. None of those is 100% correct.
Plus c.
Okay, first of all, what ones can we absolutely get rid of because you just know they're wrong?
First two.
Okay, Kaylin, what's wrong with the first one?
it shouldn't be plus cos of t.
It shouldn't be plus cosine of t because
It's the derivative of cos of.
derivative of cosine is
Negative sign.
negative sign, not what I'm looking for, but there's another reason
The
why
it's
you
the
want to get rid
variable.
of Jackie.
The variable.
Wrong variable.
I didn't see that.
Wrong variable over here. If t is your variable of integration, stick with t. That one's gone. Why is 2 the wrong answer? Because it should be, right? Derivative of 10e to the t. That is 10e to the t. That's good. But derivative of cosine of t would be negative sine of t. Okay, so it's because of this guy here that it's wrong. And the last one?
Plus, we forgot Charlie.
We forget about Charlie. Right? All the other things worked. 10e to the t, check. Derivative of negative cosine is positive sine. Derivative of 6t, 6. So you need plus c. That's your 100% all the way right answer. Everybody okay?
Yep.
There will come a time, it's called tomorrow, where I'll give you like formal derivative rules. We'll do a foldable, you'll memorize them, all the things. But all I want today is for you to use your smarticle particles. Okay, you've got them. Okay, you've got 3 minutes. You've got 7 problems. The next 5 problems. See what you can do. Rules come tomorrow. Trust your smarticle particles. Reassessment opportunity. Went over with everybody. You have to do those corrections with the reflection document. Friday. If I don't have it Friday, it's email done, out. I'm available tomorrow during lunch and Friday during lunch. You have to be there for one of those. You want to be there for both? Go for both.
3 times 4?
So I just know it's going to be x fourth minus x to the fifth plus pi x, but I don't know what to the fifth is.
Not that much harder, okay?
It's going to be 3. Yeah, the x to the fourth minus x to the fifth plus, isn't this supposed to be like,
But if you have a
Okay, here's how you really do the new free response. Let me put that in. It's for the grades. I wouldn't be surprised. You could go into the next seven. And at least tomorrow or Friday, one of those. Okay. Okay, no problem. All right.
so 1/5? So 1/5?
All right, I spent most of that time with Ashley, but I'm going to lie and say I walked around the room
X to the what?
seeing some good stuff. What's the indefinite integral of 12x cubed minus x to the fourth plus pi? Maybe you didn't get the whole thing. There are parts you should know. Antiderivative of 12x cubed is 3x to the fourth. Everybody okay with that part?
Yeah.
That's usually the part that's easy. But what about x to the fourth? What do you take the derivative of to get to x to the fourth? For sure, it has to involve x to the fifth, because what happens when you take the derivative, the power comes down.
Isn't it plus 5? I mean, plus
But the derivative of x to the fifth is 5 times x to the fourth. So how do we fix this? Definitely a negative.
1/5.
1/5. Perfect. Plus, what do you take the derivative of and get pi as your answer? Pi x.
Plus 8.
And then, don't forget Charlie. Okay, if you want to go over the little check step, take the derivative of 3x to the fourth minus a fifth x to the fifth plus pi x plus Charlie. Hey, no surprise here. Bring the 4 down and multiply, bring the 5 down and multiply, plus pi plus 0, we got it. All right, antiderivative, the indefinite integral of sine theta plus cosine theta. Indefinite integral of sine theta plus cosine theta. The question is going to be the same. What do you take the derivative of to get to sine? Negative cosine theta plus, what do I take the derivative of to get cosine? Sine plus Charlie. And for the sake of time, we're going to skip the check step.
Okay.
Okay. Next one, indefinite integral of 1 over 2 square roots of x plus 1 over x. What do you take the derivative of and get 1 over 2 square roots of x? This is why tonight's homework involves practice with the derivative rules. Okay, the answer here is the square root of x. Derivative square root of x is 1 over 2 square roots of x. What do you take the derivative of and get 1 over x? Natural log of x. Now hold on. Okay, plus c. There are calculus teachers out there right now who are like, oh my god, Mr. DeRozier's wrong and he doesn't know that he's wrong. And I know that I'm wrong. It's actually natural log of the absolute value of x, and we'll continue that conversation tomorrow. Okay, tonight's homework is all about derivative stuff. You guys are going to be fine. See you later.